All right, it's 11 o'clock Central, so we're going to get started. Good morning, everyone. I'd like to thank you for taking time out of your busy day to attend today's presentation on the use of GEOWEB Geocells in landfills. I'm your host, Corey Schneider, Business Development Manager with Presto Geosystems. I've been with Presto for 15 years and specialize in technical and site support, so I have significant experience in all of the products and applications we'll be discussing today. We are located in Wisconsin and manufacture erosion control, stormwater management, and porous pavement products that are used all over the US and the world. I have everyone muted now, so if you have questions during the presentation, please type them in the question window and I will answer them at the end. Here are the things that I hope you get out of today's presentation. We'll cover geocells in general, from development to applications, Presto's unique accessories that lead to stronger, faster installations, and then landfill-specific applications. Presto worked with the Army Corps of Engineers to develop geocell technology in the late 70s and has been innovating ever since. We go beyond simply providing a product. We have a lot of design and construction resources on our website, which is prestogeo.com. We have several experienced engineers on staff, and these engineers can provide you with free project evaluations for any application that you are considering using our GeoWeb for. And then we also provide contractor support, so either Presto or one of our local distributors will be on site to make sure that the installation goes in not only correctly, but also as efficiently as possible. And we do sell through a local distribution network, so those distributors are available to do site evaluations prior to installation as well, to make sure that the GeoWeb is a suitable product for your application. We operate in 3 product areas: soil stabilization using our GeoWeb Geocells, which can be used for load support, slope and channel protection, and constructing green retaining walls. We have a line of porous pavements, both vegetated and aggregate solutions. And then we also have lightweight reusable construction mats. Today we'll just focus on GeoWeb solutions, but I wanted you to be aware of the other types of products that we manufacture as well. We'll now move on to discuss our soil stabilization capabilities using the GeoWeb cellular confinement system in general terms, and then as they relate to landfills. As I mentioned, Presto worked with the Army Corps of Engineers to develop geocell technology. While other materials such as cardboard and aluminum were tested, high-density polyethylene, or HDPE, was the chosen material due to its lightweight, flexible nature and the fact that it is inert to nearly all chemicals and climate conditions. The GeoWeb system consists of 2 main attributes: cell size and cell depth. The cells come in 3 diameters: small, medium, and large, which we refer to as our 20, 30, and 40V, and heights of 3, 4, 6, 8, and 12 inches. Cell aperture and height are selected following an evaluation of project-specific needs and site conditions. To facilitate installation, we offer 5 different section lengths, which will help to minimize the amount of field cutting that needs to be done. The ultrasonically welded seam, where all of the connecting points are, is very important to the function of a geocell. The stronger the seam strength, the better the performance of the geocell will be. A strong seam allows for heavier infill material, steeper and taller slopes, and better lifetime performance. GeoWeb is produced using high-quality virgin, high-density polyethylene resin for consistently strong welds at cell junctions, while also maintaining semi-rigid ductile properties within the cell walls. high stress crack resistance, and overall toughness and long-term durability in the environment. Our geocells do not use fillers or exotic polymer alloy blends, which can ultimately reduce weld strength and environmental stress crack resistance, and that are offered in some competing products in the name of increasing cell wall stiffness. To avoid weld failures and the damaging effects of differential settlement, uniformity in performance across all elements of a geocell system is much more important than stiffness alone. The table on the right is a general representation for summary purposes, but it gives you an idea of the cell size and cell depth combinations that we use for each application. Again, we recommend that you use our evaluation service so that we can select the most cost-effective cell size and cell depth combination that will lead to a successful project. There are three main infill types for any GeoWeb application, depending on the type of protection needed: topsoil, aggregates and granular soils, and concrete. In most cases, geocells allow for the use of on-site materials without the need to import fill, generally with the only limiting factors being that the material should be angular and the maximum particle size should be about 1/3 the cell depth. Here we can see how the material ships. It's tri-folded, banded, and palletized, and very compact, which leads to relatively low freight costs. Obviously, depending on where in the country it goes, you're generally looking at about 1 to 3 cents per square foot in freight. The material is lightweight, so you don't need any heavy equipment for the installations. The nominal width for each section is 8.5 feet. But you can make them longer and skinnier or shorter and wider, but we do want you to keep that width dimension between about 7.5 and 9.3 feet. The length will depend on the amount of expansion and the number of strips welded together. Standard length is about 27 feet, but they can go anywhere from 16 to 58 feet. And then we can fit about 100,000 to 200,000 square feet on a truckload, depending on cell size and cell depth. In order for a geocell system to perform uniformly, it is critical that both the factory welded junctions or internal junctions and field joint junctions that connect individual panels, the mechanical junctions, perform at a level that is commensurate with that of the cell walls. The three primary elements of any geocell system, cell walls, internal junctions, and connectors, must perform uniformly as a complete system. Therefore, an incremental improvement in one characteristic is only valuable if a complementary improvement has been made to the other components of the system. GeoWeb is manufactured using a proprietary blend of high-quality virgin HDPE, and our formulation has stood the test of time for more than 40 years, and again, contains no fillers, unstable polymer combinations, or exotic polymer alloys. For most typical sites, GeoWeb will retain its durability, with lab testing indicating 149 years without degradation, even at full exposure to the elements. We stand behind our numbers so you can deliver certainty in the solution as you build with materials you can trust. Presto's GeoWeb is equipped with numerous design and construction components that increase strength and speed of installation. We have a variety of staking options, with the standard method being to use our Atra stake clip on top of a 1/2-inch diameter rebar. But if long-term corrosion is a concern, we can also provide fiberglass reinforced or plastic stakes. Atra keys are the mechanical connection that I mentioned in the previous slide. Not only do Atra keys provide the uniformity we discussed, but they are made of the same HDPE material as the GeoWeb itself, so will last just as long. Beware of manufacturers that recommend staples or nylon cable ties, as these do not have the same long-term durability as HDPE. The tendon and atcher tendon clip system is ideal for anchoring the GeoWeb on slopes without the need for stakes, which would penetrate the liners that are used on most landfills. The tendons are tied to either earth anchors or a deadman pipe, which can typically be buried in the same trench as the liner at the crest. Now we'll go a little more in depth on each of the landfill relevant application areas, starting with load support. GeoWeb can be used for both surface stabilization of unpaved roads and base stabilization below pavements. Many solid waste facilities must contend with maintaining unpaved access roads. Not only can GeoWeb save money up front by allowing you to reduce your overall cross section, but incorporating GeoWeb into the roadway section can also minimize or reduce annual costs associated with repair and maintenance of unpaved landfill roads that take a beating from heavy equipment and truck traffic. Generally speaking, the benefits of using GeoWeb in load support applications are it will allow you to reduce your overall aggregate cross section by 70% or more. It'll control lateral and vertical infill movement, which will prevent shearing, and it creates a stiff base with a high flexural strength. Here's how the GeoWeb three-dimensional system works in load support. When a vertical load is applied, the active earth pressure in the loaded cell pushes back against the passive earth pressure in the adjacent cell to form a stable system. So each cell helps support the ones around it. The GeoWeb cell walls also transfer hoop stress, which is important in keeping the system intact and creates a mattress effect. The strength of the seams around each cell, the material properties of the individual strips, and the connection method between panels are all important factors in determining how the Geocell system can improve site conditions. Strong seams, semi-ductile resin properties, and integrated connections are critical to a well-performing system. The GeoWeb system and accessories are specifically designed to work together to be an effective solution for roads in soft soil locations. Here you can see the stresses on the subgrade with the unsupported subgrade on the left and the GeoWeb reinforcement on the right. Notice how there is a complete elimination of the highest stresses at the surface when using GeoWeb reinforcement. The stresses are reduced and distributed over a wider area known as the mattress effect. This mattress effect reduces the stress reaching the subgrade and leads to significant decrease in deflection and rutting. I want to quickly review a little of the research that we've done in the past to help to increase your confidence in the use of GeoWeb. This first test, we started with a supersaturated peat mixture that was put under varying loading. Over the peat, the GeoWeb section was placed and infilled with gravel. Settlement plates were placed throughout the GeoWeb section prior to its placement, and a load beam was placed over the GeoWeb and loaded to failure. We compared this to the same depth of unconfined aggregate. So the peat pit test showed that bases reinforced with GeoWeb provide a significant improvement over unreinforced soils. For a loading of 1,000 pounds per foot, a 4-inch rut depth occurred with GeoWeb in the section compared to 20 inches without the GeoWeb. So since the previous testing was under static loads, we also went ahead and did a dynamic load test. Here the pavement load testing compared unreinforced and reinforced materials over the same subgrade. Deflection of 0.6 of an inch is assumed to lead to failure of the pavement system. Therefore, we applied the load repeatedly until that 0.6 of an inch of accumulated deformation occurred. We can see that without the GeoWeb in the section, it took 25,000 load cycles to get to this failure point. By adding GeoWeb, we were able to achieve 400,000 load cycles. So an improvement of 16 times the number of load cycles for the very same deformation. Notice the amazing strength of GeoWeb. It's strong enough to support fully loaded dump trucks that back up right to the edge of the filled cells. This project is a good example of how GeoWeb can provide cost savings. Rather than importing expensive aggregate, the on-site silty sand material was used as the fill, with only a 2-inch wearing course of aggregate required. We were also able to reduce the overall section from 36 inches to just 8 inches. So a typical GeoWeb section is going to have a geotextile below the cells, and this geotextile can be anything from a 6-ounce non-woven up to an enhanced woven, depending on your subgrade strength and maximum loads. Then your GeoWeb is typically filled with your granular material, and we do recommend a 2-inch wearing surface over the top of the cells. Now we can look at a few examples. Here the GeoWeb allowed for a structurally sound road to be built with clean stone infill. Without the GeoWeb, the stone would move with even one vehicle pass. And the clean stone and the GeoWeb perforations combine to allow this road through a wetland to be permitted, because water can flow through the cross section and we don't create any sort of a dam through this wetland area. Keep in mind, you get infiltration with clean stone only. The permeability of your infill is going to be your limiting factor. Here, an 8-inch GeoWeb and an aggregate with a 40% void space was used. This allowed for about 3 1/4 inches of rainwater to be stored in the pavement section, eliminating the need for additional stormwater infrastructure. You can also see the extremely heavy loads that are able to be handled by the GeoWeb system. Sometimes referred to as the cash registers for waste disposal, truck scales are important to just about every landfill and can also be supported using the GeoWeb cellular confinement system. The example shown here is actually a railroad scale. However, the same principles apply for truck scales. By distributing loads laterally, GeoWeb will control settlement, making scales more accurate, reducing maintenance, and allowing for longer functional life. One of the biggest questions we get is about cost, which isn't really a surprise, especially if this is new technology for you or your area. Having an idea of how much the GeoWeb system costs compared with other stabilization techniques is very important. So here we have a basic comparison for the GeoWeb system for a load support application. In this case, a gravel surface road. This comparison shows the difference in both price and cross-section depth for an aggregate-only unreinforced section, a section using geogrids and geotextiles, and then 2 sections showing the use of the GeoWeb system, one with aggregate and one with salvaged on-site materials as the infill. In all cases, we assumed a subgrade CBR of 0.5% and HS25 loading. You can see the GeoWeb system provides both thinner and less expensive cross sections, significantly so when on-site material is used. We assumed an aggregate cost of $18 a ton, and this had the unreinforced section coming in at $41 a square yard. The geogrid geotextile section at about $40 a square yard. The GeoWeb with imported aggregate at $31 a square yard. And if you have on-site material that can be used, you're all the way down to $20 a square yard. Less than half the cost of an unreinforced section. We'll now move on to discuss how GeoWeb can be used in stormwater conveyance, a critical component of any landfill design. Open channel designs with the GeoWeb 3-dimensional system offer a more economical solution than riprap, gabion baskets, or reinforced concrete, all systems that are expensive and hard to place and maintain. The cellular network creates a system of check dams that protect the upper soil or aggregate layer from hydrological erosive forces that impact unconfined material. They're much more effective than two-dimensional solutions such as turf reinforcement mats and erosion control blankets that can be subject to undermining. The benefits of using GeoWeb in channels include that it will improve the hydraulic performance of whatever infill material you use. With vegetation, we will also promote infiltration and reduce runoff. With aggregate, we can allow for the use of smaller, less expensive rock. And then with concrete, we don't need any other forms or reinforcement. And the system will flex with subgrade deformation, minimize cracking. Additionally, you can reduce your concrete thickness, leading to significant cost savings. Cell size, depth, and anchorage, as well as infill type, are determined based on channel geometry and hydraulic conditions. As mentioned earlier, free project evaluations are available on all projects, regardless of size. And a cross-section like you see here, as well as calculations, will be provided with every evaluation. Now we'll look at how GeoWeb works with the various infill options, starting with topsoil and vegetation. Generally speaking, low flow channels like stormwater containment facilities and stormwater channels can be armored with topsoil filled GeoWeb and covered with an erosion control blanket. But even in high flow situations, we have a solution that can allow you to protect channels from erosion and maintain the aesthetics of vegetation. This solution involves topsoil filled cells covered with a turf reinforcement mat or TRM. We tested this vegetated solution covered with a mid-grade TRM, not one of the newer high performance TRMs, and received great results. You can see that I was able to withstand 29 feet per second and 16 pounds of shear, which is more than twice the hydraulic resistance of 12-inch riprap and about double the performance of the new high-performance TRMs alone. It works so well because the TRM provides a cover for the GeoWeb so the cells won't scour out during high flow. And what the GeoWeb does is confine the soil directly below the turf reinforcement mat so the system won't fail when saturated. In an unvegetated condition, GeoWeb will also improve the hydraulic performance of a TRM alone by 30%. Typical applications for this system include roadside ditches, spillways, channel embankments, or dam and pond overflow systems. It's really suitable for any situation where you have very high velocities but short duration flows. And it will allow you to maintain vegetation in areas that would previously have been concrete or very large riprap. We can also provide an aggregate filled solution. Generally, aggregate is going to be used in arid regions where vegetation is difficult to establish, or for areas that are typically underwater and vegetation, again, cannot be established. So with the aggregate test, we ran a total of 90 different tests using 3 different cell sizes and 2 different rock sizes, with the goal being to develop a general rock loss equation based on varying hydraulic conditions. And with all of these data points, that allowed for the creation of a regression equation. So now, given the bed slope and unit discharge of a particular channel, we can manipulate the rock size and the cell size until we get to a point where your rock loss L is 0. When compared to traditional riprap sizing tools by Abson-Johnson and the Corps of Engineers, we can reduce the rock size anywhere from 2 to 10 times, which can lead to significant savings in rock cost as well as transportation and installation costs. I should point out that the large variance in your rock reduction is going to be due to bed slope. The flatter the bed slope, the greater we're going to be able to reduce your rock size. And finally, for your most challenging applications, we can provide a concrete-filled GeoWeb. So in this case, the concrete is going to be poured in place with no additional forms or reinforcement required, as the cell walls will function as both. And it will allow for easier to place higher slump concrete. It is a flexible system that will withstand settlement very well, which is of course quite important in landfill applications. And then we also assure uniform concrete depth, because you just fill right to the top of the cell walls. And typically we can replace a 5 or 6 inch depth of reinforced concrete with just 3-inch GeoWeb filled with the very same concrete. Once anchored in the channel, the GeoWeb allows concrete to be pumped or poured right into the cells. And again, we screed it right to the top of the cell walls. Notice the flexibility of the concrete-filled GeoWeb panel in the photo on the right. It's not going to crack like poured-in-place concrete will. Again, the system was tested at Colorado State with very impressive results. Our mid-sized cell, just 3 inches deep, was able to withstand 36 feet per second and 21 pounds of shear. And we actually didn't even fail the system, but rather maxed out the flume. Now a few examples. The regional municipality of Waterloo in Ontario, Canada, faced the challenge of creating an effective yet simple method of erosion prevention while removing stormwater from their newly capped cell at the Cambridge landfill. The protection system had to be durable and stable under a variety of hydraulic and mechanical stresses. Concrete-filled 4-inch deep GeoWeb panels were selected due to previous in-ground success with the system, the ability of the concrete to limit vegetation growth in the bottom of the channel, and the overall flexibility of the system to conform to potential subgrade movement. A total of 15,000 square feet of GeoWeb was installed at the landfill, and the system was anchored with stakes in channels varying from 7 to 20 feet wide, with bed slopes of up to 14.5%. The perforated GeoWeb system maximizes the mechanical bond between the concrete and the cell walls, locking the concrete infill into the individual cells of the system. The concrete-filled system forms a uniform thickness mat which controls concrete quantities and costs. The system prevents uncontrolled cracking of the concrete and reduces the chances of piping or undermining. Next up is a project that we did at a landfill in Hong Kong. And here's some of the specifics. So used at a Hong Kong landfill, it also incorporated energy dissipators, which were designed using recommendations provided in design of small dams by the U.S. Bureau of Rec. This is a 460-foot drop from top to bottom with design flow rates of 350 cubic feet per second. And they also expected a maximum differential settlement to be over 30 feet within the first 15 years. Here we can see the location of the baffle blocks, which were used for energy dissipation in both cross-section and longitudinal section. The blocks were placed in the channel invert as well as on the side slopes, approximately every 8 feet downstream. Now we'll take a closer look at the installation. Here you can see the X's that were placed on the geotextile underlayment to mark the location of the energy dissipator blocks. The GeoWeb was then placed and cut at the block locations to make room for the energy dissipators. Next, the blocks, which weighed about 500 pounds each, were placed. It's hard to see here, but the blocks are tapered from bottom to top. This way, when the concrete is poured into the cells, the blocks are locked into place. Finally, the concrete was poured with some of the slopes being in excess of 20%. Note the change in infill type with concrete on the bottom and up the sides, transitioning to topsoil and vegetation at the crest and on the back side of the berms. With the GEOWEB system, transitioning to different infills to handle various hydraulic conditions is quite easy. The channels drain not only the top of the landfill, but also drain across the landfill through flexible piping buried a few feet below grade. And we can see one of those pipes in this photo here. Finally, we move on to slope protection. GEOWEB is a state-approved product for use in landfill capping applications. As of May 2020, it was recently added to the North Carolina Department of Environmental Quality guidelines for addressing pre-regulatory landfills as an approved technology for use in soil cover systems. As mentioned earlier, tendons and attra-tendon clips allow for anchorage without penetrating geomembranes. Tendons, which can be either polyester, polypropylene, or Kevlar, are either tied to a buried deadman pipe or earth anchors, and the entire system is draped from the crest, with the tendon clips serving to distribute the load so as to not overstress any of the welds. The number and type of tendons, as well as the clip spacing, are provided as part of the evaluation process. Here we see an example of a tendon system over a liner. Again, no stakes are needed, allowing the integrity of the liner to remain intact. This is a pond at a golf course in Tennessee, and they didn't need to protect the entire slope as the water level varies only along the length of the GEOWEB panels. The GEOWEB serves to prevent soil erosion in the areas of water level fluctuation. Here's a borax mine in Southern California, again using tendons and tendon clips over a liner. In this case, the GEOWEB was used for an access ramp into a large containment pond for cleanout operations, and it was placed at a 45-degree angle across and down the slope for the access. In vegetated solutions, confinement prevents topsoil from washing out during rain events and/or with fluctuating water levels. Here's another project, this one at a waste disposal site in Brazil. You can see we have significant erosion after the failure of the initial two-dimensional cover system that was selected. Here's the permanent solution, consisted of a geomembrane covered by the GEOWEB, which is anchored using the tendon system. Many times the deadman pipe can be placed in the same anchor trench as the liner for ease of construction. 1 year after the installation, we've got a fully vegetated, erosion-resistant vegetated cap in place. Here we have a highway slope where iron pyrite was exposed during excavation. When exposed to air and moisture, there's the potential for acidic runoff with elevated concentrations of contaminants. Here the slopes were covered with a geomembrane, and aggregate-filled GEOWEB was placed over the liner as a protective layer. The slopes were up to 1.5 to 1 and up to 200 feet high. While not a landfill, landfill design principles were used. Finally, a project from 1997 that does not involve a geomembrane, but rather preventing erosion of a 200-foot high slope at 1.5 to 1, and the slope was basically shale. This is at a solid waste transfer station in Jefferson County, Alabama. Other solutions were looked at, such as riprap, which was too expensive, and building a retaining wall at the bottom of the slope to collect the inevitable erosion, which would require too much maintenance. Eventually, the solution that was selected included a 4-ounce non-woven geotextile to provide separation and an in-plane drainage layer, and then 3-inch topsoil-filled GEOWEB panels. The system was then hydroseeded and an erosion control blanket was installed. Well, normally hydroseeding and using erosion blanket is an either-or proposition. The idea here was to create a complete system that would eliminate the need for any chance of future maintenance being needed. Here we can see the results 2 years after the installation in 1999. You can see we've got a nice stable vegetated slope. And 15 years after the install in 2012, we start to see some tree growth on that slope. And again, you don't see any erosion at all and full vegetation. And finally, we've got very impressive performance 25 years after the installation. This year, took these photos in March, I believe. In summary, every project is different, but the GEOWEB system has a solution that is right for you. The GEOWEB system can be added to road projects to provide a more stable and longer lasting surface course for unpaved areas, which will reduce maintenance and repairs. For paved surfaces, GEOWEB decreases pressure on the subgrade to reduce differential and long-term settlement, which will extend pavement life. The ability to use low-quality aggregate or even sand can save a significant amount of money. Whether you are looking to stabilize your roadway, protect your embankments, or manage your stormwater runoff, the GEOWEB system has great flexibility of design to meet your project needs. And it is a complete system solution for ease of installation and peace of mind. To reiterate, we do offer a free project evaluation for any potential project, regardless of size. That process starts with a request for project evaluation form, which can be found on our website, prestogeo.com. You can see the free project evaluation button right here. And within 3 business days, but usually faster, we provide a complete design evaluation, including infill recommendations and anchorage requirements. We will work with you to get you the best design for your project. We send project-specific CSI specs with each evaluation, but if you have the need or desire to create one on your own, we have a spec maker tool available on our website. And this will allow you to create a full project-specific CSI spec as a Word document in a matter of a few minutes. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specs so you can deliver certainty and build with materials you can trust. So hopefully we covered all of the learning objectives to your satisfaction. If you would like to discuss anything in more detail, you can contact me directly. We've made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of on-demand webinars completed along with PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand webinar dashboard, so you won't find your certificate from today in there, but you will receive an email from GoToWebinar within the next 24 hours containing a download link to obtain your PDH certificate. In 2 or 3 days, you will also receive a separate email from Presto Geosystems with more information about accessing the on-demand webinar dashboard with other helpful resources. If you do not receive either of the previously mentioned emails, please check your spam folder. So here is my contact info if there are questions that come up later. I do want to thank you for attending and remind you that you can always send questions to us at any time at info@prestogeo.com or directly to me at the email listed here. Go to prestogeo.com for a wealth of information, and don't forget to view our YouTube videos found by clicking on the YouTube icon in the upper right-hand corner of our web pages. I'll answer questions next, but if you have questions I don't get to or think of one later, you can respond to the follow-up email and we will be happy to answer your questions with project recommendations. So now I will check the question box and see what we've got in there. Do you have any specifications of what type of fill material is needed for the GeoWeb? Again, it's going to depend on application. Typically, again, with aggregate, you want it angular in nature and a maximum particle size of 1/3 the cell depth. We do recommend a clean washed stone if permeability is an issue. With concrete, the slump is basically controlled by the contractor on site. You just want it to be able to flow into the cells. And topsoil, we just want a high quality pulverized topsoil. Next question, is the woven geotextile required in pavement structure? Could a non-woven be substituted to limit fine particle migration? Yeah, if it's a woven or a non-woven will be controlled by site-specific conditions. So if you have a preference, you can include that in the project evaluation form and we will honor your preference. But yeah, I mean, the main function is going to be the separation. Beyond that, the project specifics will dictate what type of geotextile is required. You have to vibrate the concrete. Again, we want to stay away from vibratory compaction all the time because we don't want that material to get underneath the cells. So just regular screeding of the concrete is all that's needed. Where can I obtain a copy of this presentation? Again, there's on demand. These webinars are available on our website at any time. So that looks to be all of the questions. There is one about PDFs being available. We covered that at the end, so we should be good. Again, I want to thank everyone for attending today. And if you do have any questions, feel free to call me at 920-738-1304 or shoot me an email at corey.schneider@prestogeo.com. Thank you very much, and we'll be signing off.